Hi, everybody. This is review for test 3. What I did was I looked at the test, then I looked at this review in the workbook, and then I picked problems similar to the ones that are on the test. And I'm just going to write down the questions that I'm going to cover today. So if you want to write these down, number 2, 6, 7, 8, 14, 19, 25, 29, 31, 32, 37, 38, and 39. These are the problems I'm going to cover in this workbook for the test review. So these are the ones I'm going to cover. All right. Starting off with number 2, solve, tell me what x equals. I need to get x's to one side. You know, step 1, there's no distribution. Step 2, combine like terms. These two cannot be added together. These two cannot be added together on each side separately because one's a number, one has an x. So then step 3 was get all the x's to one side using add and subtract. So I'm going to take this 9.9, negative 9.9 to the other side, because if I take it to the other side, it'll be a positive on the other side, and then my x will be positive. I just like to have a positive x. You don't have to, but I like having a positive x. So I'm going to add 9.9x, add 9.9x. I'm left with 1.3 equals negative 23.6 plus 8.3. 9.9 minus 1.6 is 8.3x. Okay. Now I need to get x by itself. I have to get the 8.3 to the other side and the negative 23.6 to the other side. Can somebody tell me which one goes to the other side first, the negative 23.6 or the 8.3? Anybody? Oh, no.
23.6.
Thank you. I was going to say, oh, we're in big trouble. Oh, please take this test serious. This is, I think this is our first test that we're using Respondus Lockdown Browser. It's multiple choice, but if you can't work these problems out, you're going to have a big problem here. So yes, we're taking the minus 23.6 to the other side. It's a minus, so I'm going to add 23.6, add 23.6, and I'm left with 8.3x. Change that color. On the right-hand side, 8.3x. On the other side, I'm left with a 9 and a 24, 24.9. 1.3 plus 23.6. Okay, so now I need to just get the that to the other side, divide both sides. It's 8.3 times x. So we're dividing by 8.3. Dividing by 8.3. And I'm left with x equals 24.9 divided by 8.3 on my calculator is just 3. There's my answer. All right, so we finished one problem. Any questions? Stop me. Please, please take this test serious. For some reason, after spring break, people start laxing and thinking, oh, this is going to be an easy class, or just they just start relaxing too much. So make sure you take it serious. Don't want any bad things happening. Question 6 is next. Now, there's a couple of ways of doing this. I'm going to do it the same way I did it when we went over this section. If you remember what I did here, this is x plus 2 over 3. What I did was put x over 3 plus 2 over 3. I did that denominator actually goes underneath each one, or you can do the whole thing or underneath each one. So I'm going to leave it under each one. Same with the other one, x over 7 plus 4 over 7. So there's another way of doing it, but I don't think I showed you how to do that where you can cross multiply and all. If you can do it another way and get the same answer, it's fine. So now I need to get all the x's to one side. And it doesn't matter which side you bring the x's to. I'm going to bring the x's to this side. So I am going to subtract x over 7. And remember, to get x's to one side, you add or subtract the x. It's a positive x over 7, so I'm going to subtract x over 7. Here, I end up with and I'm left with 4 over 7 on the right-hand side. Let me put this in black. And I have a 2/3 over here. And then I have this. So this is 1/3 x minus 1/7 x. See, there's an invisible 1 here. When you don't have anything in front of an x, there's a 1. So it's 1/3 x minus 1/7 x. On my calculator, I'm just going to do 1/3 minus 1/7. Two fractions. I'm not putting the x's in. I'm just doing 1 over 3, 1/3 minus fraction 1 over 7. And when you do that, you get 4 over 21x. 4 over 21x. Okay, 1/3 x minus 1/7. So 1/3 minus 1/7 is 4 over 21. All right, so we're still solving for x. I need to take the 2/3 to the other side and a 4 over 21. You always take the add and subtract to the other side first. So I'm going to, it's a plus 2/3, so I'm going to add 2/3, add 2/3. When I do that on the left-hand side, I'm left with that 4 over 21x. Then I just have to put that in my calculator. This cancels out. And I just have to put 4/7 plus 2/3 on my calculator. Fraction 4 over 7 plus fraction 2 over 3. And I get 26 over 21. All right, so the last step, let me erase this. This was the last answer.
I thought it was supposed to be negative 2/3.
Yes, it is. Thank you. I put a negative here and I forgot to put it there because I can't see my own writing. So it's 4/7 fraction 4 over 7. See, I need someone to keep tabs on me. Minus fraction 2 over 3. And I get, oh, okay, so that changes it drastically. I get negative 2 over 21. 4/7 minus 2/3. 4/7 minus 2/3, yes. Okay, so now I just need to take this 4/21 to the other side. The easiest way, it's multiplying, so I'm going to divide both sides by 4 over 21. Divide this side by 4 over 21. That cancels out, and I'm left with x equals. So I'm going to put it in my calculator exactly like that. I hit fraction. Then on top, I hit fraction again. And I put negative 2 over 21. Then I go to the bottom and I hit fraction again. And on the bottom, I have 4 over 21. And when I put this into my calculator, I get negative 1/2. If anybody's following along, check my work. If you're not following along, shame on you, because come test time is the wrong time to try to learn how to do this. It's so important that you are able to do these things. Just to get through this course, we don't want to take it again. I don't want to see you again in my class. Unless you're going to take calculus, because I'm teaching calculus over the summer.
No, I will never be taking calculus.
No.
No.
All right. So that's the second problem, number 6. I feel like I'm going way too slow, but there's not many that we have to do here. So I'm going to erase all this. I also teaching statistics over the summer in case anybody wants to take statistics.
No.
I think eventually I'll have to take that, but not, yeah.
Yeah, certain majors have to take the statistics also.
Math in general is just a no.
Yeah.
I'll be taking statistics this summer.
Okay.
Is statistics hard or is it not?
No, I think it's easy, but I'm teaching the online version, so where there's no lectures. Everything's in video, though. I have all the videos laid out just as this course, but there's no set. The way I'm teaching it all online, so I offer help, but there's no lectures that you're required to go to.
I will not be doing math like that.
Okay, so there's a problem similar to this on the test. Can you put that in your calculator and come up with the answer? Let's try it. See if you can do this on your calculator, and then I got my camera here. I can show you also. I didn't think I was going to use my camera today for my calculator camera. Try to get this answer, and then I'm going to go ahead and put it in the calculator. Okay, so it's the third root of negative 729. The third root of negative 729. To do that, remember, we're going to be using this up arrow button right above it is the X with the root. So we're going to hit, so the third root, you have to hit 3 first and then hit second arrow up, which gives that, do you see? It puts that 3 into the upper position into the root. And then we put negative 729. Don't hit subtract. You have to hit negative 729. And the answer to this is negative 9. Everybody okay with that on the calculator?
Yes, sir.
Yes.
All right. And this is being recorded, so you'll have this also. For some reason, I don't have the review recorded already. So this is going to be a new recording. All right, so let's go back. And I have a different version of this. So this answer is negative 9. My question to you is, what if I had this? What is the answer now? Anybody know what the answer now would be? Well, remember, you can separate, if things are multiplied together, you can separate the items inside. This, we know, we just did it, is negative 9. Now this, if I have a third root and the third power, they cancel. So I'm just left with x. Third root and third power cancel each other, and we're just left with x. If I have three x's and third root, one x pops out. And so this is what the answer would look like if there was an x to the third inside. Same way with the square root of 25x squared. Square root of 25 is 5. You know, there's an invisible 2 here. The square root of x squared is just x. If it's a square root and a power of 2, they just cancel and then the x pops out. Square root of 25 is 5. All right, I erased all my numbers. So I'm going to number 8 next. Put that in your calculator. Anybody dare to say what the answer is? Oh, no. Oh. Anybody dare to tell me what they got for an answer?
81.
Oh, you got 81?
Is that 77 at the bottom of 8?
I have no idea.
It's like 77 or 27.
I think it's a
27.
27.
I have the book open.
It's a 27. There we go. It's a 27 because I thought it was
I got
70.
81 too, but I know there's another answer for this.
No, the answer is 81.
Oh, then what is the radical notation?
Okay, so changing it to radical notation, the 27, radical means the root. Remember, the bottom is the root. So this is the third root of 27. The top is the power. And so you normally do the root first before the power. Do you see? If the third root of 27 is 3.
Oh, yeah. Okay, I get it now.
And then 3 to the fourth power, 3 times 3 times 3 times 3 is 81. So the answer is 81. You do the root first, the third root of 27, because 27 is 3 times 3 times 3. If you have 3 of them multiplied together, one pops out. And then you do the fourth power, 3 to the fourth power is 81. Good. So this 27, 3 to the fourth power. You can put the 4 inside here, or I think it's easier to put the 4 outside here. You can put it either way. I like to keep it on the outside. And this is the radical notation. Change it to radical notation. There it is. And then simplify. Well, this equals 3. 3 to the fourth power equals 81. Okay. Next is number 14. And the instructions for this say solve for x. So we have to find out what x equals. Now, this was the rational equations where, if you remember, we had to factor everything on the top and bottom that we could. So this doesn't factor, this doesn't factor. But what did I say about, my question to you is, what did I say about this? Do you remember? I know I said it a couple of weeks ago, but what did I say about this? I mean, we have to factor it, but what's a hint? What's the hint about this factoring? Anybody? Well, the hint about this factoring is it's probably going to equal what's over here. So when you factor this, 24 is 1 times 24, 2 times 12, 3 times 8, 4 times 6. How do I get a 5, a plus 8, and a minus 3? Do you see a plus 8 and a minus 3? This factors to x minus 3, x plus 8. The hint is that it usually, not all the time, but usually will end up being a factor of the stuff that's already been put together. So so we have to find the LCD. Let me erase all this other stuff. And remember the LCD, if you remember this, said was you take that bottom, then you take that bottom, and then you take this bottom, but we already have an x minus 3 and we already have an x plus 8. So we're done with the LCD. Now we multiply each fraction by the LCD. We multiply 3 over x minus 3 by, boy, let me separate it all first. And then we're going to multiply this, x plus 8. And then we have an equal sign, and then we have this 5 over, and I'm going to leave it in factored form, x minus 3, x plus 8. So you have to multiply each of these fractions by the LCD. So I'm going to multiply this by x minus 3, x plus 8. I'm going to multiply this by x minus 3, x plus 8. Multiply this by x minus 3, x plus 8. If anybody remember us doing this? It was true. Then you cancel anything you can. These two cancel. And I'm left with now just 3 times x plus 8. I'm left with this and this. These two cancel, and I'm left with, that's an 8. And I'm left with 7 times x minus 3. And this cancels with this cancels with this, so I'm just left with 5. So this is what I'm left with. When you multiply by the LCD, the fractions disappear. So then we solve for x, we distribute. 3 times x is 3x, 3 times 8 is 24. Then plus 7 times x is a positive 7x. That's a 24, not an x. Looks like an x. And then I got 7 times a negative 3 is minus 21 equals 5. The steps were distribute now for solving. We did the distribute. Combine like terms, 3x and 7x on this side of the equal sign is 10x. 3 plus 7 is 10x. 24 minus 21 is a positive 3. I get the 3 to the other side by subtracting 3. And I got 10x equals 5 minus 3 is 2. Then divide by 10, divide by 10. And x equals 2 over 10, which reduces to 1 over 5 when I put it in my calculator. So the answer to number 14, x equals 1 over 5. If I did everything correctly, hopefully I did. So the key, if you remember, is find the LCD, multiply each of these fractions by the LCD. That gets rid of all of the bottoms. And so then you're just left with this to solve for x and go through the solving steps. That was number 14. You will have one of those on the test. Every problem I'm doing for you will be very similar to problems that are on the test. There will be problems very similar to this one. Number 19 is next. Okay. So pay attention because there is one of these on the test. I can't stress that enough. We're going to use the square root principle. I'm not even sure what it just says solve. It doesn't tell you to use the square root principle, but we're going to. So in order to use the square root principle, when you have a square root, you need to get the square root by itself. I need to take the x to the other side. It's a minus x, so I'm going to add x to both sides. I'm left with the square root of 2x plus 15. And the x went to the other side with a positive 6 over there. Instead of 6 plus x, I'm just putting x plus 6. Okay, so you have to get the square root by itself, because once you get the square root by itself, then the opposite of square root is squaring both sides. So you have to square both sides. Square root and square cancel. So I'm left with 2x plus 15. If this cancels with that, I'm just left with the 2x plus 15. On the other side, though, you have to do x plus 6 squared. So that's a little harder because I'm not sure if I showed you this. I'm sure I showed you this before, but x plus 6 squared, it's the same thing as 5 squared. 5 squared means 5 times 5. 9 squared means 9 times 9. X plus 6 squared means x plus 6 times x plus 6. And we have to distribute this. We have to FOIL this. X times x is x squared. X times 6 is a positive 6x. Then you do this. 6 times x is a positive 6x. And 6 times 6 is a positive 36. So you get x plus 6 squared. You have to write it down twice and FOIL it, and this is what we end up with. Now, when these two can combine, so I'm left with x squared. 6x plus 6x is 12x plus 36. Now, when you solve for x, you normally get x on one side, everything else to the other. However, when you have an x square, you have to take everything to the x square side because you're probably going to factor. Minus 2x, so I'm going to put the minus 2x right underneath the other x. Plus 15, so I'm going to minus 15, and I'm going to minus 15 here. So these all turn to 0. And then I'm left with x squared. 12x minus 2x is a positive 10x. 36 minus 15 is a positive 21. So I'm going to bring this over here. I got 0 equals x squared plus 10x plus 21. And then I'm going to go ahead and factor it. 21 is 1 times 21. 3 times 7 is 21. A plus 3 and a plus 7 give me a plus 10. So it's x plus 3, x plus 7 equals 0. And so then x plus 3 equals 0, or x plus 7 equals 0. Get the 3 to the other side, x equals negative 3. Get the 7 to the other side, x equals negative 7. So these are my two answers. However, what could be tricky about those two answers? What do you have to do with these two answers? You have to check them. When we do square roots, you have to plug them back in to make sure they work, they hold true. So I'm going to start off by putting negative 3 everywhere there's an x. Maybe I should just rewrite it. Or 2 times negative 3 plus 15. This equals negative 6 plus 5. This ends up equaling the square root of 9. And then if I put a negative 3 in minus a negative 3, minus a minus changes to a plus. The square root of 9 is 3. 3 plus 3 does equal 6. So this is a good answer. Now I'm going to try negative 7 in here. 2 times negative 7 plus 15. 2 times negative 7 is negative 14. Negative 14 plus 15 is the square root of 1. So we end up with the square root of 1. And then I put a negative 7 in here. A negative and a negative 7. Square root of 1 is 1. A negative negative changes to a plus 7. 1 plus 7 is 8. It doesn't equal 6. Since when you put negative 7 back in here, it doesn't equal 6. That's not a good answer. You cannot write it down. There is only one good answer here. You have to plug them both in. On the test, I promise you, it'll say something like this. The answer is negative 3, negative 7. The answer is negative 3. The answer is negative 7. The answer is none. Only one of them is the answer because the other one, when plugged back in, does not work. So the correct answer would be this one. So you have to check your answers and plug them back in to make sure you get a true statement. And that was number 19. There's a lot of work involved there. I would definitely go over these problems again and have the steps and procedures. I promise you one of these will be on the test. So don't say, oh, maybe that one won't be on. It's going to be on. We're going to number 25. Write the inequality in interval notation. So if I normally graph things first, x is greater than or equal to -2. Here's -2. Greater than or equal to -2. Since there's an equal sign, we use a bracket, and greater is that way. So when we put it in interval answer, the answer in interval notation, the far left has a bracket, -2. The far right goes to positive infinity. You can never touch positive infinity, so there's our answer. That's it. Okay, I have another question for you. Don't look at this one anymore. Let's do this one. Don't look at that one anymore. What's the answer to this one?
X is greater than or equal to the -2.
Yes. What I was looking for is it's the same problem. X is greater than or equal to -2. It's the same as this answer over here. I wanted you to make sure that you can read it from this way, X and then greater than -2. If you're going to read it backwards, you still have to go X, start with X, greater than -2. So I just wanted to make sure that you understand both of those are exactly the same. The X and then greater than -2. They both read and answers exactly the same. You always start with the X and then you go towards the other stuff. So on this one, you're going to go read it this way. On this one, you're going to read it this way because you always start with the X. Thank you. Just want to make sure everybody understands that because we talked about that already and I just want to re-emphasize it. That was 25. Let's go to 29. Solve and graph the inequality. So we need to solve this. Combine, it's just distribute. You know, the same steps for solving. Step 1, distribute. There is no distribute. Step 2, combine like terms. -9 and -1 is a -10. -9 minus 1 is a -10. There's still a 12x in front of it. These two ended up being -10. I'm going to get all the x's to one side. So I'm going to bring the 11x to this side by subtracting 11x, subtracting 11x. And 12x minus 11x is 1x or just x. Take the -10 to the other side by adding 10, and x is greater than or equal to 7. So you find 7 on here, x is greater than or equal to 7. Interval notation is 7, and it goes to the right is positive infinity. That's the answer in interval notation. Mhm. The test is multiple choice, but I've seen people fail multiple choice tests miserably. Please study. Please know how to do this. Be caught up. I'm hoping everybody's caught up on their homework, because studying can't happen until homework's done. I tell everybody that. It's hard to study if you haven't done the homework, because on the homework, you're just trying to complete it. After you do the homework again, hit similar. And can you do the same problems, similar problems, without any help, just using your notes? Because a lot of people get them wrong and wrong and wrong and wrong. Oh, then I got it right. Okay, but you got it wrong 3 or 4 times. On the test, you can't try 2 or 3 times. You have to get it right every time. All right, so here's the equation. And I'm gonna put it over here, x minus 2y equals -8. And the first part is this: complete the ordered pair. What is this ordered pair telling me? When it says complete the ordered pair, what do I need to find? I mean, to do this problem, you have to understand, what are you looking for? What are you trying to find?
The y.
Yes, ordered pairs, thank you. Ordered pairs are x and y. The x equals 0, we have to find y. So we're gonna put a 0 in the x. We have to find what y equals. Well, 0 minus 2y is still a -2y. Divide, I need to get this -2 to the other side. It's multiplying, so I'm gonna divide by a -2. And y equals -8 minus 2 is a +4. When x is 0, y is a +4. That dot on our graph, x0, y4, is right here. That's one dot on our graph. Okay, now I'm going to erase what I just wrote down in red. And I'm going to do the next dot. This time, we already said that was a 4. This time, our y is 0. So I'm going to put x minus 2 times y. Y is 0 this time. Do you see? The second part is y. We need to find what x is. And -2 times 0 is 0. X minus 0 is still x. X equals -8. So when y is 0, x is -8. So -8, 0 is right here. And by the way, this is an equation for a line. So if these line up, there's our equation. I'm going to do one more to show you that all these dots should line up no matter what we use. I'm going to do this one now. X is 3. So here's the equation. I'm going to put a 3 in the x. It's 2y equals -8. Get the 3 to the other side by subtracting 3. -2y equals -8 minus 3 is -11. Divide by -2. And y equals -11 divided by 2 is a negative, I'm going to use the decimal, 5.5. So when we put a 3 in the x, we get a -5.5. X is 3, y is 5.5, right there. You see, it still falls on the line. If you drew a straight line, every dot will fall on this straight line. And you'll have to fill in, I think on the test, I don't think you have to graph it, but you do have to fill in the missing pieces. If they give you y, you have to find x using the equation they give you. And that was number 31. Number 32 is also on my list, which means the same type of problem is twice on the test. Here's the equation. So you're going to have this same, two of these exact same type of questions. We have 4y equals negative 2x plus 8. And first they tell us, put a 0 in the x and find y. So I'm going to put a 0 in the x. Negative 2 times 0 is 0. I'm left with 4y equals 0 plus 8, which is 8. Then I need to get the 4 to the other side. It's multiplying. So I'm going to divide by 4. And y equals 8 divided by 4 is 2. So 0, 2. X is 0, y is 2. There's a dot right there. Then I'm going to put a 0 in the y. 4 times y, 0, equals negative 2x plus 8. 4 times 0 is 0. That's an 8. I got to take the 8 to the other side by subtracting 8. Negative 8 equals negative 2x. And then I got to take the negative 2 to the other side. It's multiplying. So I'm going to divide by a negative 2. And x equals negative 8 divided by negative 2, which is a positive 4. So when y is 0, x is 4. So this is the other dot. Connect the dots and we have the answer. And if you want to put a 1 in there and find the answer, I'm going to say the answer is somewhere around there, like 1.5 or something like that. If you put a 1 in the x to find y, you'll see what the answer is. It should line up on that. All right, that was 32. Got 3 more problems to do. What's 37 is next. Write the augmented matrix for the system. How easy is this? Make sure the x's and the y's are by himself and the numbers on the other side of the equal sign. So this becomes 8, 9, and 28. Here, there's nothing for x, so we put a 0. For y, it's a positive 5, and for the number, it's 20. We're done. That is the augmented matrix. Just so long as the x and y are on the left-hand side by themselves, and the numbers without the x and y's are on the other side, this is how you write the augmented matrix. Number 38. Use Gauss-Jordan to solve the system. So first we're going to write the augmented matrix. The x's and y's and numbers are all lined up. We have 6, 3, negative 12. And we have 2, 7, 10. Remember how we do this. Our goal is to get it to look like this, where we have a 1 in this spot. And I'm trying to figure out. One in this spot. So you could subtract, add, divide. I'm going to divide. So I want this to be a 1, and I see that this is a power of 6 also. It's a factor of 6. 12 divided by 6 is 2, but this is not. So I'm going to divide. So I'm going to create a new, remember, this is row 1, this is row 2. I'm going to create a new row 1 by taking the old row 1 and dividing it, each item in old row 1 by 6. If I take 6 and I divide it by 6, I get 1. If I take 3 and divide it by 6, I get 1/2. If I take negative 12 divided by 6, I get negative 2. I didn't change this row at all. Okay, so that was our goal, to get a 1 here. Now I need to get a 0 here. I need to turn this 2 into a 0. And it's always good to use subtraction when you're trying to get that into 0, especially when you have a 1 up there. So now I know I have to change row 2 because I need to change this to a 0. So I have to change row 2. I'm going to take the old row 2 and subtract row 1. 2 minus, this is row 1, this is row 2. 2 minus 1 is not 0. So I have to put a 2 here. Do you see? Row 2 is 2 minus 2 times row 1. So because I need to get a 0, I have to put a 2 in front of that row 1. 2 minus 2 will give me 0. So let's see what I get when I take all of row 2, each item in row 2, and subtract 2 times row 1. Well, 2 minus 2 times 1 is 2. 2 minus 2 is 0. Next, I'm going to take this one. Take that is a 7, and I'm going to subtract 2 times row 1, 1/2. 7 minus 2 times 1/2 is 6. 2 times 1/2 is a negative 1, so 7 minus 1 is 6. And then finally, I'm going to erase this. Then I have a 10 in row 2. Here's my 10. And then I'm going to do subtract 2 times row 1. Row 1 is a negative 2. 6 minus a minus 2 minus times a minus 2 is a positive 4. 6 plus 4 is, what am I doing? Why did I put that right there? I was supposed to put it up here. 10, this ends up being 10. A negative 2 times a negative 2 is a positive 4. So I end up with 10 plus 4. I end up with a 14 right here. Okay. So row 1 stayed the same. 1, 1/2, and negative 2. So I had 10 minus that and got 14. Okay, so we got this first one, we got this second one. Now we have to turn this into a 1. One way of doing it is just dividing everything by 6. I'm going to change row 2. I'm going to take the old row 2 and just divide it by 6. Each number in the old row 2, and I'm going to divide it by 6.
Wasn't the original R2 supposed to be 2, 7, 20, not 2, 7, 10?
Hang on. 2, 7. Oh, now you tell me. I'm telling you, I'm blind. I can't see that. She's saying back here a half an hour ago, this is supposed to be 20. Yes. See, you have to be able to write the augmented matrix correctly. So we didn't change row 2, so that's still a 20. Now we changed row 2. We took the, okay, so now we took this row 2 and 2 times that to get 0. Take this 7, 2 times that, that's 6. Now we're going to take this row 2 is 20, so that should be 24. That works out a lot better. Thank you. Because I'm still, so this should be 24 now. When we put 20 in there, 20 minus 2 times a negative 2, that's 20 plus 4. So that should be 20 plus 4, which is 24. Now, when I divide this row by 6, it turns out, 0 divided by, you're taking old row 2, 0 divided by 6 is still 0. 6 divided by 6 is 1. 24 divided by 6 is 4. And row 1 never changed. So we're almost there. Thank you. Yeah, because I was it's gonna end up being some miserable fraction. I looked at it and said, oh no, answer's gonna be a miserable fraction. We have 1, 0, 1, and now we have a 0 here. We have to change that to a 0. This has to be changed to 0 somehow using subtraction. Okay, so I am going to change row 1 because this has to change. That's row 1. I have to change that to a 0. So row 1 is going to change. And in order to change row 1, and I'm going to take the old row 1, that 1/2, and I'm going to subtract row 2. Well, 1/2 minus 1 is a negative 1/2, but that doesn't make sense. I have to have a 0 in this spot. So 1/2 minus a negative, minus 1/2 times 1. So do you see R1 is 1/2 and R2 is a 1. Now, when I put this in my calculator, I get 0. Okay, so for that spot, that second spot. Let's do up here. I'm going to start with the first column, this first column. Row 1 has a 1 in it, minus 1/2 times 0. 1 minus 1/2 times 0 is still still 1. 1/2 minus 0 is still 1. And then we already said this was 0 because we're going to put negative, or we're going to put positive 1/2 in here. And when we subtract 1/2 times 1, 1/2 minus 1/2 is 0. So we got to do the last one. And in row 1, in the last one, we have negative 2. Subtract 1/2, whatever's in row 2 in that spot, 4. So negative 2 minus 1/2 times 4. Negative 1/2 times 4 is a negative 2. So it's negative 2 minus 2 is a negative 4. So this is what we end up with. We have to have 1, 0, 1, 0, just like we did. We work this way, and then up this way. Somebody tell me what my answers are, though, because, okay, here, A, B, C, D, and the answers are this, or this. What is the answer?
D.
Yes, it's D. X is the first one, is negative 4, and Y is the second row, it's 4. So the answer is D, where X equals 4, Y equals negative 4. And it can be written in coordinate form. X goes first, Y goes second. And we have one more problem to do, number 39. Pay special attention to number 39. One of these will be on the test, same as 38. Okay, our goal is to change this to 1. Remember, our goal is to make it 1, 0, 1, 0. Change this to 1. Oh, first of all, I have to put it in matrix form. Somebody tell me what I did wrong. I did something wrong. I'm supposed to put it in matrix form, but the matrix form is wrong.
It's supposed to be a positive 10, a positive 25.
Yes, you can't put it in matrix form until the 10 is on the other side of the equal sign. It has to be X, Y, and then the number on the other side. It's a minus 10, so you add 10 to both sides, and a positive 10. It's a minus 25, so you add 25 to both sides. So a 10 is a positive 10 is on the other side, and a positive 25 is on the other side. This is what the matrix form looks like. The 10 and the negative 25 are on the wrong side. The X and Y's are on the left side. The numbers without the X and Y's are on the right side. So this is the matrix form. For some reason, I thought that, wait, I think I picked the wrong question. Give me a second. Let me look at number 40. I think I have the wrong question that I wanted. Yes, I need to do, I need to do 40 or 41. I picked the wrong question. I'm sorry. I think I'm going to do number 41. Okay, so, and don't forget, I said our matrix form looks like this: 2, 5, -7, -6, -15, and 21. I need to turn this first number into a 1. But remember what I said, and I did it in class. I'm going to switch these two rows, and I'm going to tell you why in a second. -6, -15, and 21. 2, 5, and -7. I switched. So, I mean, if I wanted to put it, you can just write switch R1 and R2. I just switched some spots. It doesn't matter because I need to turn this into a negative. I need to turn that into a 1. And so I'm going to change my row 1. I'm going to create a new row 1. And in order to change this row 1 into this -6 into a 1, I have to divide it. By -6. Let's do that. Let's go through the process, and then I'll show you an easier way of doing this. So I'm going to take row 1 and I'm going to divide it by -6. Everything in row 1 and divide it by -6. So the first item in row 1 is -6. -6 divided by -6 is a +1. -15 divided by -6 is a +5/2. When you put -15 divided by -6, they both divide by 3, and I get 5/2. I get a +5/2. And then 21 divided by -6 is positive divided by negative is a negative. They both divide by 3, 7/2. So next I need to change row 2. I need to change that to a 0. So I'm going to change row 2, and I'm going to take the old row 2 and subtract row 1, but I have to multiply it by 2 because 2 minus 1 won't give me 0. 2 minus 2 times 1 will give me 0. So this creates, row 1 is going to stay the same. Row 2, 2 minus, so this is 2 minus 2 times 1. I end up with 0. Next, I'm going to put the next numbers in here. Row 2 has a 5 in it. Minus 2 times row 1 is 5/2. When I do that in my calculator, 5 minus 2 times 5/2, I get 0. And then when I put the last number in there, -7, row 1 is -7/2. Do you see? I'm putting -7 for row 1 or row 2 and -7/2 for row 1. And when I get that, I get 0. I end up with 0, 0, 0 on the bottom. What's my answer? So here's possible solutions. The empty set. -7/2. Many solutions. D 5/2. What's the answer?
C.
Yes, when these are all 0, the answer is many solutions. There are many solutions. Now I can't remember how it was worded on the homework, but it's not the empty set. Empty set means no solution. And I'm going to show you a really quick way of doing these where you don't have to go through all this. So let's look at this. Look at row 2. Look at row 1. If I multiply row 1 by -3, 2 times -3 is -6. 5 times -3 is -15y. -7 times -3 is +21. Do you see, if I multiply that top row by -3, I get the exact same thing as the bottom row. If you get the exact same thing, then there are many solutions. Now, let's look at so in other words, when I add these up, if I subtracted them, I end up with 0, 0, 0. We end up with 3 zeros. So if you get the exact same thing when you multiply one row by any number that you can to get the exact same thing, you end up with many solutions if you get 0, 0, 0. However, let's look at number 40. If I multiply row 1 by -1, I end up with negative 2x. By negative 1, I end up with positive 7y. By negative 1, I end up with positive 5. The bottom is negative 2x plus 7y. It looks the same, except one number, the last numbers are different. These are the same. If you added these up together or subtracted them, you'd get 0, 0. If you subtract them, 5 minus 7 is negative 2. Do you see? You get 2 zeros, but then you get a number. This one is no solution. The empty set. If you get 2 zeros and a number, it's the empty set. But if they all match up exactly, and if all of these are the same, then you get many solutions. So if the two look the same, you just multiply by a row. This one, there is the empty set, no solution. However, 41, because they all look exactly the same when you multiply it by a number, you see you just multiply this by 3. Multiply this by 3, multiply this by 3, and they all look the same, or negative 3. Once you multiply every item by negative 3, they look the same, so there are many solutions. Many solutions if you get 0, 0, 0, no solution, or the empty set if you get 0, 0, and a number. All right, that is the test. There are 20 questions on the test. We covered about 13 or 14 of them. The other ones that I didn't cover are like repeats of what we've already done. There are a couple other ones that I didn't cover, but I'm hoping that you still got them. I can't give you the entire test. There was just a couple other ones that were a little different, but you should be able to do them. All right. That's all I had for the day. I'm going to hang around if anybody has any questions. Don't forget, on Thursday when you come to class, we're going to cover new material that will not be on the test, but we have to cover that new material. Your test will be this week, Friday, Saturday, Sunday, or Monday. You can take it whenever you want. You have to use the Respondus monitor to get it to come on. And so go to the orientation module, take that easy quiz again to make sure your Respondus monitor works. All right, you guys have a good day. I'll see you Thursday. I'll hang around if anybody has any questions or wants me to cover any problems or anything like that. Bye, y'all.
A good one.
Have a
You
good
too.
one.
Bye-bye. Anybody have any questions? Or did you guys all fall asleep? Pedro, did you fall asleep? Lucy, Aiden. You guys all fell asleep? Mm-hmm.